SOA XMP practice question number 26. A startup is pitching its new product to 4 potential investors. The startup estimates that the probability of securing an investment is 0.8 for each of the first 3 investors, but only 0.1 for the 4th investor. The investment decisions of the investors are independent of one another. Calculate the probability that at most 2 investors commit to funding the startup. Let's take a look at the solution. The first 3 investors will invest with probability 0.8. The 4th investor will invest with probability 0.1. We need to calculate the probability that at most 2 investors commit to funding the startup. P of at most 2 invest equals 1 minus the probability that at least 3 invest. And this equals 1 minus the probability that exactly 3 out of 4 investors invest, minus the probability that exactly all 4 investors invest. The probability exactly 3 invest, the expression, the first term is 0.8 cubed times 0.9. The first term 0.8 cubed corresponds to the first 3 investors all make the investment. And then the 4th one does not make the investment, which is 1 minus 0.1, 0.9 here. And then the second term corresponds to the event that only 2 out of the first 3 investors will make the investment. We have a binomial distribution. 3 investors, only 2 invest, times 0.8 squared times 0.2. And then times the last factor, 0.1, corresponds to the last investor who will invest in the startup. Upon calculation, we get the probability that exactly 3 out of 4 investors make the investment is 0.4992. And then we also need to compute the probability that all 4 investors will make the investment. This equals 0.8 cubed times 0.1. All investors invest. So we multiply all the 4 probabilities together. We get 0.0512. Substitute these 2 probabilities into the expression. And we get the probability that at most 2 investors commit to funding the startup equals 0.4496.